Okay, so we're going to start on, today we're starting on chapter 2.1, right? So chapter 2.1, and we are going to solve equations with rational coefficients. Solve equations with rational coefficients. Which sounds kind of technical. So before we get into this, let's figure out what that means to us. Okay, so solve means we're going to get an answer. How do you know if something is an equation? Equation means it has a what? What do all equations have? They have numbers, yes. What else do they have?
Variables.
They have variables. Say it again, Drew. An equal sign, okay? So an expression is just like a line of numbers, like 2 plus 3, okay? If it actually has an equal sign, something like 2 times x equals 6, okay? If it has an equal sign, that's called an equation, okay? So equations just mean it has an equal sign, okay? So has equals sign, okay? With rational, what does rational mean? We learned about this last unit. What is a rational number? Do you remember? How do you know if something is a rational number? You just don't want to say it. Okay, rational means it can be changed to a fraction. Okay, so rational means could be written as a fraction. Could be written as a fraction. And what does the word coefficient mean? Does anyone remember? Does anyone know what is a coefficient? You've probably heard about it before, and you've probably even used that word, but you might not know what it actually means. Does anyone know what a variable is? What's a variable? Ariana, what's a variable? A variable is just a number, or a letter, excuse me. A variable is just a letter, okay? A coefficient would be what? Court, did you know it? Oh, never mind. A coefficient is just a number in front of a letter, okay? So a coefficient is a number in front of letter, or a number in front of a variable. I should use the right words, sorry. Okay, so a coefficient is a number in front of a variable. So today we're going to be solving equations that have fractions or decimals in front of a variable. Okay, so we're going to be solving equations with fractions basically, or decimals. Okay, so another term that I need to make sure that you know, and I think you might already know this, but just in case, is something called multiplicative inverse. Multiplicative inverse. Okay, a multiplicative inverse. A multiplicative inverse. So, in your books, what I would like you guys to do is let's open up to page 111. Okay, I want you to open page 111. You don't have a page 111? Oh, you don't have your book. Okay, well, then you can just write it on a piece of paper. That's okay. Okay? And we're going to do this graphic organizer. We're going to define it, describe it, list some examples, and list some non-examples. So non-examples just means things that are not a multiplicative inverse. Okay, so I want you to look in here, and for define it, does anyone happen to know what is the multiplicative inverse? The technical definition of multiplicative inverse, and I'm going to do the little graphic organizer just on my paper, okay? So for the define it part, the technical definition of a multiplicative inverse is two fractions that multiply to give 1. Okay, 2 fractions that multiply to give an answer of 1. Not 1 fraction, but 1 as in the number. Okay, 2 fractions that multiply to give 1. So let me give you some examples. Okay, so an example of a multiplicative inverse would be 2/3 and 3/2. Okay, 2/3 and 3/2. Can anyone else give me another example of a multiplicative inverse? Or how would you describe this? How could you describe a multiplicative inverse? If one of them would be 2/3 and 3/2. What are you noticing about what happened with these fractions? They flipped. Okay? So if you describe it, this would be when the numerator and denominator do what? Switch places. Okay, the numerator and denominator of a fraction switch places. Okay, so the numerator and denominator of a fraction switch places. That's what it means to be a multiplicative inverse. Okay, can anyone give me another example of a multiplicative inverse? What if I gave you 4? What would be the multiplicative inverse of 4? Court? Say it again. 1/4, exactly. If you have just a whole number like this, remember how when we did negative exponents, if I wanted to make it a fraction, I could just put it over 1. Then its multiplicative inverse or fraction flip would be 1/4. Okay, so you can make any number, any whole number or fraction into, or excuse me, you can find the multiplicative inverse of any whole number just by giving it a 1. Okay, now some non-examples. What does it mean to be a non-example? Something that's not it. Okay, I want you to know that what if I gave you 2 1/3 and 7/3? Why is that not a multiplicative inverse? Because this is a mixed number, and this is what? This is an improper fraction. So these are really what? The same thing. Okay, it's just writing it from a mixed number to an improper fraction. This is not a multiplicative inverse. Okay, what about 1/2 and negative 1/2? Are those multiplicative inverses? No. Okay, those are just negative and positive. Okay, so being a multiplicative inverse has nothing to do with positives or negatives. Okay, so multiplicative inverse, it doesn't even know what's another word for multiplicative inverse. Starts with an R that you might have heard before. Say it again. Not ratio, but reciprocal. Okay, some of you might have heard this as a reciprocal. Okay, so I'm going to write AKA. Does anyone know what AKA stands for? Also known as. Just wondered if you guys knew that. Okay, AKA reciprocal. Or a fraction flip. Okay, has nothing to do with being positive or negatives. Okay, not at all. So, first thing we're going to do is let's find some, let's see. Okay, so we already went over a coefficient. Let's see what else. Okay, so if I ask you to solve, okay, your instructions are going to ask you to solve. So for example number 1, if I ask you to solve, I just lost my place, sorry. Solve 2/3 A, I'm going to write capital A's because my A's look weird. 2/3 A equals 12. 2/3 A equals 12. Now, the way that we solve, anytime you have a fraction, okay, we basically want to, how is the 2/3 attached to the A? By add, subtract, multiply, or divide? By multiplication. How do we typically undo multiplication? Division. Don't write this part down. But would it make any sense to do like this, to divide that away? No, you just created this is what's called a compound fraction. Okay, I would call it a double-decker fraction because you have a fraction over a fraction. So anytime you have a fraction and you want to solve, we are going to use the multiplicative inverse. Okay, usually we would divide and that's fine. Okay, but here, since you have a fraction, we want to use what's called the multiplicative inverse. And the multiplicative inverse is the fraction flip. So what would I multiply 2/3 by to get rid of it? 3/2. Now, if I do it to one side, what do I have to do to the other side? Same thing. Okay? It's kind of like a balance beam. Okay? So I want you guys to all hold out your arms. Okay, hold out your arms. Don't hit each other in the face. Side to side. Hold out your arms. Hold them out. All of you. You're not doing it. I feel like you're not doing it. Yeah, I know, because I see half of you not doing it. Okay, if I was like a scale or a balance beam and I have 2 pens on each side, okay, I'm balanced, right? What if I took one away out of one hand? Then what would happen? One side would be heavier. So if I wanted to be back in balance, what would I have to do?
Take away another one.
Take one away from the other side. Okay, so you want to think of equations or equals sign kind of like a balance beam, okay, or like a scale. Okay, if you take something away from one side, you have to take something away from the other side. If you multiply something on one side, you have to multiply on the other side. So you have to be fair. Okay, here, what happens with 3/2 and 2/3? What happens there? I don't know who taught you this. But in math, there is no such thing as cancel, okay? What really happens with the 2 and the 2?
They turn into ones.
They really turn into ones, right? 2/2 is equal to 1. What happens really with the 3/3? They turn into ones. Now, do you really have to write 1a? No, you don't really have to. But I want you to get rid of the idea that they cancel in your head. Okay, they reduce to equal 1. There is no such thing as canceling. Okay, you can reduce to equal 1, but don't think that they just poof, automatically go away. It doesn't happen. Okay, so 1a equals, how would I solve this one? 12 times 3/2. You could add a 1 underneath. What do I want to do here? Do I want to multiply across the top and then reduce, or what would be an easier way to do this? Cross reduce, okay? What can reduce with this 2? The 12 and the 2 can reduce to leave you a 1 and a 6. Then you multiply. What's 6 times 3? 18. So, technically it's over 1. Do I have to write over 1? No. Okay, so you don't have to write like this. So really, we just get A equals 18. That's your answer. Okay, have we seen stuff like this before? I feel like you probably have, right? But some of you are looking like you have no idea. Great. Okay, let's try another one. Okay, number 2. Okay, number 2. I would like you to solve, okay, and again, we are solving. I would like you to solve, let's go, -24 equals -6/7 p. -24 equals -6/7 p. Where do you think I start? How is the -6/7 attached to the p? By add, subtract, multiply, or divide? By multiplication. So to get rid of it, I need to do what? Use the what? Multiplicative inverse. Okay, when you use the multiplicative inverse, what would I have to, what is the multiplicative inverse there? What's the fraction flip of 6/7? 7/6. Now, can I just multiply by 7/6? Why? Because you forgot the negative, okay? The negative has to go with it, okay? So the negative is still important. So here, what happens with the 7s? They reduce to equal 1. What happens with the 6's? They reduce to equal 1. What happens with the negatives? They multiply to become positives. So what do you end up with on the right side of this equation? Just a p, okay? 1p. On this side, what can I do? The negatives will cancel. And then what happens with the 6 and the 24? They can cross reduce. So 6 and 24 reduce to be what? 1 and 4. And then multiply across the top. What's 7 times 4? 28. Positive or negative? Positive, because I had 2 negatives and they went away. So answer here would be 28 equals P. Question so far. Is this boring or confusing? Both? This is confusing? Okay, because you guys, maybe it's just Monday, but I'm feeling like you're either not understanding or just zoned out. Okay, that wasn't really an answer. All right, next one. Let's try for example number 3, sorry. Okay. Again, I just want you to solve. Okay, so I want you to solve and let's figure out, sorry, this is still saying solve. Okay. I would like you to solve, let's do, sorry, I keep losing my place today. 10.8 equals 0.9n. 10.8 equals 0.9n. 10.8 equals 0.9n. So, which variable, what's the variable that I want to get by itself? The n. Okay, I want to get that letter by itself. How would I do that? Any ideas? How's it attached to the number? By multiplication. So if it's attached by multiplication, how do I undo it?
Division.
Divide. So I'm going to divide both sides by what? 0.9. So divide both sides by 0.9. Okay, what happens here is these reduce to equal 1, so we just get 1n. You have to actually do this, though. You have to do 0.9 into 10.8. 0.9 into 10.8. So where should my decimal place go?
Away.
It doesn't just go away. Oh, you're saying you can move it over? Okay, I can go with that. Okay, so since there's one place in each, you can move it over. 1. Is that what you're saying? Okay. Then, how many times would 9 go into 10?
1.
1. Multiply through, that gives you a 9. Then we do what?
Bring down the 8.
Subtract, so 1, bring down the 8. How many times does 9 go into 18?
Twice.
Twice. And then what? Do I have to put another decimal place in there?
No.
No. Okay, you do not have to put another decimal place in there. Okay, so 1n equals 12.
Yeah.
Questions on how I did that? Let's try another one. You guys are being really quiet today. Okay, let's try another one. Number 4. Okay, and this will be the last one because we're not doing a ton of stuff today. Okay, so for number 4, I would like you to try negative 5.6k equals negative 12.88. Negative 5.6k equals negative 12.88. So what do I have to do? Divide both sides by what? Negative 5.6. Remember, you have to take the positive or negative. These go away to get 1k. Equals. What happens with the negatives? They become positive. And then we're going to do 5.6 into 12.88. What do I do with this decimal place? I can move it over how many times? Once. So that means I can move this decimal place how many times? Once. So automatically, if you move it over once, you need to bring it up here. Then we need to figure out how many times would 56 go into 12? It doesn't, right? How many times would 56 go into 128? 2. Okay, so I want you guys to finish this out. You do the multiplication and do the long division for me. Yes. Okay. Dustin, write it down.
Oh, I did.
I'm not done yet. How could you be done?
We're not calling ahead.
Oh, you went ahead? What'd you get? Nope. So, a lot of you guys at 23. What's wrong with that answer? 2.3. Okay, don't forget you can't lose that decimal. Okay, and yes, that's the answer that I'm looking for. So K equals 2.3. Now, do I have to have the 1 in front of here?
Nope.
No. Okay, you could just write K by itself. Okay, it doesn't really matter. Do we have questions on how I did that? Okay. For your homework, you're going to be working on page 115. Okay, and today we're going to work on numbers 1 through 6 and 19 to 24. Okay, 1 through 6 and 19 to 24 in your book. So there's not that much in there. You probably have time to finish it in class. If you do finish it in class, let me know, and I'll give you a stamp for extra credit.